Howdy. Yeah, there's a lot going on all over the place. And for some reason, we are watching a 24 hours of quakes. Let me show you. 24 hours. So there's something going on. Earth may be getting charged or something. Because we have the southern Finland conductor going through somewhat here. And there's a lot of quakes. 9 hours ago. 2.2, which is in a way a rather strong quake for this area. 10 kilometers in depth, this doesn't tell us anything because they are always 10 kilometers. They don't tell us. Yeah, some quake activity in Scandinavia, near Doggerland as well, 7 hours ago. 5 kilometers in depth, so that's rather shallow because it's covered with water there as well. And quakes are measured from sea level. There's a deeper quake in Switzerland 3 hours ago. 27 kilometers depth. Yeah, we will talk about water, mountains, and let's see what else things. But how to put it? There's not only quake-wise very much going on, also weather-wise, as probably many of you know. We had floods all over the place. There are still floods going on. Many of the places of big floods, they weren't really in the news. Of course, we had Spain and Northern Carolina, America. But there are many other places, like the Balkan region. There are also many floods. There's been Italy and earlier Austria and that region. But now we want to talk a bit about Valencia. Yeah, now you probably understand of why I started with this map with earthquakes, because we have Valencia at the center of the screen. And on this side we have Confrentes, volcanic field, probably extinct. Eruption style unspecified, none during the last 10,000 years. Lopez Ruiz et al. And this Lopez Ruiz et al., so there's a bunch of people who made obviously some paper in 2002 where they mapped out many of the volcanoes in the region. Columbretes Islas, volcanic field, 33 meters, probably extinct. Eruption style unspecified, none last eruptions, none during the past 10,000 years. A group of islands in the Gulf of Valencia was mapped by Lopez Ruiz et al. 2002 as quaternary in age. The three largest islands are Ilha Grossa, Ilha Ferreira, and Ilha Foradada. So, and there's also, this I just noticed it when I started to make this video, which is an attempt to surprise myself about making this, because I've been thinking about this a lot and I wasn't really able to do it. Now I just try to surprise myself. And as I started, I noticed that there is something going on. 30 kilometers in depth, 1.7, 17 hours ago. Maybe there's two at the same place. Let's see. If you click it, no, there's just one. 16 hours ago, 2.2, 8 kilometers in depth. Alicante, Valencia, 16 hours ago, 2.18 kilometers in depth. Yeah, and obviously we cannot really see the seafloor here. It's blurred out for some reason. Yeah, there would be probably a lot of interesting stuff there. But Valencia, Torrent. This was something that really stuck out like a sore thumb when I started to watch what's around Valencia. Torrent. To me, this sounds like torrent, a stream of water. And I've been, of course, following and watching what's going on there. And I guess we have seen some of the footage. It's brutal, you know. And it's also been talked about that how no one warned the people from the flash flood. That happened basically somewhere else. It didn't really, like, it was probably also raining in Valencia, but the downpour didn't happen there, so the flash flood came from the mountains. That's why it surprised the people. And I have to read to you some parts of my Mountainwater paper, and probably you will hear the same things again. So I was watching some news. I don't really remember what kind of channel, what country, but some official news about the floods. And the reporter mentioned the river Turia. Here we have a sign where we can read it, if I can just turn it around. But anyway, Turia, probably, yeah, disappears as you get closer, or it splits in two. And there is also this kind of water basin here. Maybe some mining operation. But anyway, it seems you don't have to dig very deep where you are there in order to find water, the groundwater. Yeah, of course. You probably know that what you see from a river is only a small fraction of the river itself. Most of the river is basically flowing beneath the ground. Of course, it depends on the geology. In some places, it's just deep crack, basically. In some places, it's wide. It depends. But there's a lot of the river what you cannot see. This also means that when it's flooding, yeah, of course, there's also a lot of water in the ground flowing. The energy is much bigger. And it was very interesting to me to hear that someone basically said that it was the river that did it. Now let's just read a bit of this. Water everywhere. Record flash floods hit Valencia in Spain. And what I want to point out is 13th of November 2022. 2 years ago. Yes, obviously, Valencia is a place where we have frequent big floods. And some of them, they were really big. Maybe we will talk about the Great Flood of Valencia in the past. I don't remember exactly when it was. In the 60s or something, maybe. But anyway, it could be older. But there has been one very big flood. And I think maybe that was the reason why they tried to make something to the river. It's not the first time this year that the region in eastern Spain flooded, as the area saw record rainfall in May. Of course. So 2.5 years ago, it was there flooding. So it's flooding there all the time. And after watching several news reports and stuff about the floods, there were people, one reporter was actually living there, and he or she was obviously in shock about what happened, but still, because he or she was a TV reporter and was reporting about the stuff, when she or he tried to explain it, you saw how difficult it was. And that also told me that how shocked the person was. Never seen anything like that. Many people in Valencia, they haven't seen anything like that before, despite they are used to get more or less frequently flooded. So this event, as the one in America or in the US, they were unprecedented. The first news that came out from North Carolina, Asheville and stuff like there, they were talking about 100-year floods. And a few hours later, they were talking about 300-year floods. And maybe 2 days later, they were talking about 1,000 years floods. Yeah. Even 100 years floods, probably. No one in the region has ever experienced something like that. Because you probably need to be more than 100 years old. So, now we go over to the NCGT Journal, an international journal for new concepts in global tectonics. Volume 11, number 1, March 2023. I will put a link below to this. You can read all the other papers until you come to my paper. Archaeology of the concept of time in the ancient Western, Eastern and Far Eastern cultures, the foundations of physics. Pockmarked seep sources and degassing processes in the polar region structures. Comparing plate tectonics and expansion tectonics. Mantle gravitational anomalies in zones of different endogenous Earth regimes. And mountain water. Yeah. This time I chose to keep it rather short with the title, because the other papers carry a very long title. A new approach to mountain forming, volcanism, glaciers, and the role of water in an electric environment. So now, abstract. People settle near water. Almost all life forms need water. Water is very important for life on Earth. Consensus theory explains the circle of water through evaporation, precipitation, and accumulation. Meteorologists don't know much about volcanoes. Volcanologists don't know much about weather. This paper is a thought-provoking new approach to the formation and activities of the Alps and many of its features as a part of the greater environment. It is also meant as a serious warning for millions of people living in the Alps region, which spans from the North Sea down to the Mediterranean Sea and from the Black Sea to the Atlantic. Yeah, Mediterranean. Valencia. Massive changes in the environment have been taking place in the past, and it is crucial to understand that we are dealing with cyclical events. They are recurrent and will happen again in the future. When you scroll down a bit, you get to this picture. It's from the UNESCO, and pile dwellings. I have been there once, or maybe twice, or maybe more often, because I went to school in Switzerland, so we made this kind of day trips. And I think I have been there several times. Figure 6. Pile dwellings of the Alps region. There are more than hundreds of these. Gives an overview of the surprising amount of pile dwellings around the Alps. The pile dwellings at Unterhuldingen are reconstructed and turned into a museum, which is a part of the UNESCO World Heritage Sites. Okay. Let's just read a bit here because very often, if something happens in Central Europe, like landslides, floods, or quakes, they are not considered as related to volcanic activity by the local officials. They may explain it as related to a mining operation, bad weather, or something related to the geothermal industry, induced quakes or something, but never to volcanism. There are a few places to go hiking in glacial caves, and many mineral springs are known about for hundreds of years. In the Serfaus-Vis-Ladis region in Austria is the country's highest bottling plant. The spring was discovered in the year 1212 by a shepherd. The sour water was famously known as far as Russia. Eventually, an earthquake occurred in the year 1671, which lowered the outflow significantly. The many meters high fountain disappeared after the quake. It must have been quite a sight in the year 1212. How many similar things occurred in the Alps since the time of creation? No one knows. The Alps region is also known for its pile-dwelling settlements. Some are dated back as far as 5,000 years. Many of the settlements are submerged, but some are reconstructed and function nowadays as museums. According to archaeologists, the reason for building houses on piles is most likely preventing wild animals reaching the settlement. This never made any sense to me. I wondered why they just didn't build a fence. This theory suggests the reason for building houses on pillars, clearly elevated from the ground, might have been the occasional floods or occasional flooding. In ancient times, flash floods may have occurred much more often, because the region was much more active volcanically and geyser-like eruptions happened frequently and on a much larger scale. We could imagine ancient people being very aware of the danger of flash floods. They also knew that water from mountain springs can also be very healthy. Maybe they had observation posts along known paths of flash floods and kept watch on certain eruptive sites. When an eruption occurred, someone was blowing into a horn to warn the people downstream, and they went up into their houses waiting for the flash flood to go by. Maybe this was also the reason why someone invented the Alp horn. It was a huge instrument, or it is a huge instrument, and can be heard from great distances. It also could be that the Iceman, Ötzi, was a watchman for the villagers downstream and he drowned in an eruption because he was simply too close. That's why there was just one person found in another settlement. Another possibility is that he was a tactical target. It was discovered that he was badly injured and probably died through bleeding out. So yeah, if he was injured, he couldn't run away, so he drowned. I don't know. We must assume that the Alps region was home to many different tribes and groups of people. You still recognize if you go to the Alps region and if you are able to speak the local language like Swiss German or something, or French, and if you go from one valley to the other valley, people speak different. And sometimes if you go far enough, they speak very differently. So back in the days, I think those languages, they were probably even more differentiated. But anyway, some tribes needed someone to watch out for the water. Some tribes didn't have to. If there was some rivalry going on between tribes, it would have been a very tactical and strategical hit to kill the one watching. If he's gone, then maybe also the rest of the rivals are gone soon if an eruption happens and the settlement gets destroyed. There are archaeological artifacts emerging from so-called ice patches from all over the world, like in the Yukon area. Perhaps these ice patches were once warm wells, in other words, heating springs, which attracted not only humans but also animals. A sudden eruption of water made them drown, or gases took away the breathable air. So now I just have to show you a few things in order to, yeah. For those who don't know what I'm talking about, in order for you to catch up. And I didn't really have prepared this video too much. It is very important to understand that electromagnetic fields are coupled, i.e., there is no electric field without a magnetic field, and where you find a magnetic field must be an electric current. If the magnetosphere gets compressed, those different layers may break, i.e., disrupting connections, because this releases a large amount of energy. Things are happening very fast and violently. The energy which was flowing in the layer will make a connection to the ground, and it manifests itself as a somewhat local event and leaves geological scars on the surface of the Earth. Geology is studying petrified artifacts of the weather. Similar events were happening elsewhere on Earth too, but as all other natural events, they represent only a part of the bigger chain of events. The effects of these disruptive events deeply impact the environment. As earlier mentioned, atmospheric layers will discharge when compressed enough. This can happen through cloud-to-cloud, ground-to-cloud, or ground-to-ground discharge. If there is hot plasma like lightning, we have to speak of an arc discharge event. As a possible proof for this claim, we can examine volcanoes on both sides of the arc. Yeah, we are talking about the Alps region. You just saw the pile dwelling picture where the Alps were in the middle, and I'm talking now about the volcanoes in Italy and the Eiffel volcano complex in Germany. As a possible proof for this claim, we can examine volcanoes on both sides of the arc, north and south of the Alps. Their history correlates also in their timeline, i.e., cosmic cycles. The volcanoes are basically holes burned through the mantle by very strong electromagnetic discharge events, making the connection to deeper layers where we find magma and hot water. Even though the actual event is over, the energy exchange between ground and atmosphere continues. It doesn't have to be always a volcanic eruption. Very often we find that these spots influence weather patterns. Giovanni Gregori has done extensive work on the Sun or Earth-Sun connection theme. The following picture, figure 10, illustrates the continuous connection between ground and sky, which is therefore a circuit and will react immediately according to the environmental electromagnetic changes. The environmental changes Earth experiences are mainly driven by the Sun, and the Sun's environment changes accordingly to the changes in the connection to the center of our galaxy. So we are watching at the Joule antennas. They are going through several layers in Earth, and they will continue upwards through all the layers of the atmosphere. As shown here, and we can say there would be a high pressure system, a low pressure system. The high pressure system is where the energy goes in. The low pressure system is where the energy goes up. We don't really have volcanoes here in Finland, which is in a way a pity. Yeah, there are many, many volcanoes, but not the ones you know about, or not the ones you would imagine as a volcano. But anyway, use what you have, use what you got. There is some industrial stuff going on here, and obviously there's a layer going here. Now let's zoom in a little bit. There's this layer, and then we have this cloud going up, but it turns and there is a space basically in between. We could call this maybe a double layer. And here it makes a connection to the next layer. So the layer gets in a way compressed, maybe. We could call it maybe compressed because there's something pushing from below, so it gets compressed. And it breaks. And in the background, where we have this layer, and it's also layer because here obviously you can see there are no clouds, but here are no clouds, but there's clouds in the middle. But the thing is, these lights, these are the top lights of the exhaust pipe. What is it? There's this, I don't know the English word for that. It doesn't come to my mind now. And there you can see, because this pipe is exactly at this height, everything that comes out of that can't travel on. Because obviously there is a bigger spacing between these layers and the upper layer. And it seems that at this point there might be another layer. I think I have another picture of that same thing a little bit later. Yeah. There must be another layer here, because the cloud seems to dispatch and it seems also to dissipate. So we have now here many layers, and here's also something like there's something bulging through. It already reached a higher level, so it can. If I would have been staying there for a longer while, if there's a line, this cloud would rise and it probably would spread to the sides, at least to some degree, and after a while it probably would punch through this layer as well. Maybe it would easily punch through if the layer isn't that strong. And if you haven't noticed, there's also some northern lights in the background, really faint. And here's a sketchy GIF with a volcano in the background that exhibits lenticular clouds. And I don't really remember what volcano this could be, but it doesn't really matter. It is a volcano, and it's not that uncommon to see these kind of lenticular clouds. And I think the other overlay is from Walter Russell with his tornado theory, with the vortices, and something similar we can see here on the volcanoes with these lenticular clouds, because I really think the clouds, especially these easily visible layered lenticular clouds, are expressions of the magnetic field. Because Earth's electrical field is aligned vertically. In other words, because the magnetic field is perpendicular to the electrical current, the clouds are horizontal. That's why the clouds are horizontal, because they are basically the expression of the magnetic field. The auroras are more vertical because they are more the expression of the electrical field. And that's an even more sketchier overlay of a cloud picture I took once. And you can very briefly see what Ben Hyde did recently in his garage with his plasma discharge. Let's see if I can stop it at the right... I don't know how you can stop a GIF here. No, it just continues. Anyway, here you can see it side by side. And what happened with Ben Hyde's plasma there, I think they lowered the vacuum in the chamber. In other words, from very low pressure more to ambient pressure, which is very interesting. And there are so many similarities. For example, this section here looks very similar to this section here. Then I still haven't found the video of this cloud because I have a video of this. You can see how these things are moving. Yeah, I make a video when I find it. And that's a third little overlay in order to undermine somehow my point in what we are going to dive in a little bit more as we go on, is about how geological features affect the weather. Obviously, we are in the middle of the Atlantic Ocean, and there is no land in sight for hundreds of miles. Here we have, I think, the Azores somewhere, and La Palma here on the lower right. But otherwise, there's nothing like land there. But nonetheless, all these clouds form amazingly just over the ridge, over the mid-Atlantic ridge. In other words, when meteorologists explain that there's like weather coming and it smashes into some mountains and it's raining because of the mountains there on the land, like the Alps, for example, or in Spain, it might be only partially true. Because if it does, if the weather does the same thing over the open sea, where we don't have any mountains sticking up, there's just water as far as you can see, then the reason for the downpour might be also something else than just the mountains. So it might be helpful for many to think often in a way in vortices. Everything is basically spinning around something in a way or another. And if you have energy going from A to B in whatever form, if you just would have the possibility to crank it up, there might be some really physical reaction at the other end. Let me use a basic example for what I mean. Let's say energy is light, is information. You get a message on your phone and you watch it. And it's not a good message. And basically you're watching light coming from your phone in the form of pixels. So there's not really a connection except if you have the phone in your hand. But if you don't have, like you just look at something, like let's say a phone, and there's not a real, or like, how to put it, not a really physical connection to the phone itself. There's only the thing you are looking at. Nonetheless, if the bad information is charged enough, so the content of the information has, let's say, severe influence on how you feel, and you maybe start to cry. You probably would share a tear or two as you cry. Afterwards, you feel different. Tears are made of different things according to the reason for why you're crying: anger, happiness, sadness, sorrow, whatever. They are different. So, the information that gets into you gets transmutated into actual matter, into tears, and the body discharges with water, so to say. So there would be a very interesting science investigation about tears. What are they made of? What are the elements of feelings? What's the element of anger? What's the element of sorrow? If tears are made differently according to the reason for why you are crying, there must be something in them. So, back to the paper, Mountainwater. Water streams and clouds, repetitive patterns, aren't only present in biology. Like a tree always forming the same shape of leaves, for example, they are also present in geology. Some visible with the naked eye and some aren't. The invisible repetitive patterns in question are cyclical events like eruption rhythms. The actual eruption and its consequences are visible. But the timeline pattern can not be seen unless numbers are used, put in a row and compared to each other, like in nature. With only one number you won't get the solution, you need something to compare, at least one other number. You will end up searching for a repetitive pattern made out of numbers. This undermines the strength of repetitive patterns as evidence with or without numbers. Numbers aren't found anywhere in nature, and nothing starts from zero. Numbers are just a tool and not the explanation itself. They can be used to make things visible, but also to obscure them. The Alps aren't just a random accumulation of rocks which every now and then get wet through rain or freeze over in wintertime. It is a very active area. Thousands of wells, dozens of glaciers, rockfalls, landslides, flash floods, geothermal activity, many holy places, and thousands of people living there. It is all part of the bigger picture. The mountains are active, alive, and they interact with their environment continuously, mostly silently, without causing any harm or interruption in the environment. Yes, and so we have to talk about North Carolina, Appalachian Mountains, stuff like that, because when I was writing the Mountainwater paper, I was reading about the area. So it was very interesting, and there would be so much to talk about that. But I just figured to, like some days ago, to try to find some maps about North Carolina, what's going on there, geologically speaking, and waterly speaking. And that's some kind of a flood prevention map or something. I will put a link below to this site as well. There's like some 341 maps or something. And that's just one part of the map. Ja. Oota hetki, mennään kohta. Niin. Anyway. And it was very interesting. Because the pattern reminded me of how it looks when you put electricity into a wet wooden board and it starts to burn its way through it. It amazingly creates the same pattern. Yeah. That also goes back to what I explained earlier about mountain forming with the electrical discharges and stuff. This is how it looks, or like, that's hot when it's in action or creating the features. But since we are talking about geology where we have different material than wood and much greater powers included, so what is remaining from this electrical discharge are the water veins, because water is the thing that makes the connections. So with that being said, if don't think like when I mentioned the Alps here in this paper, it doesn't mean only the Alps, basically all the mountains, basically everywhere. So the Alps are just an example. The area in America that got flooded is quite similar to the Jura Mountains in Switzerland, where I grew up. There's a lot of limestone and stuff. Yeah. And there might be also hot springs and like things like that in the area. But anyway, it would be an endless video to cover all the things. So let's just go on and take the Alps just as an example for many other mountains. Almost all of them. Anyway, people depend on the activity of the Alps. They need the water pouring out of the rocks. Their activity and aliveness is the very reason for people living there since thousands of years in the first place. As shown earlier, there is a continuous energy exchange happening between ground and sky, everywhere. What do you think? When you go outside your door and you're outside, where does the heavens start? It starts beneath your feet. This is where the heaven starts. And if you go outside and it's foggy, you are in the clouds. The heaven came down to earth. And there's like billions of people running around being scared, not going to heaven when they're dead. Totally unaware of being in heaven all the time. Just go outside your door. When it's foggy, you're in the clouds. Anyway, as shown earlier, there is continuous energy exchange happening between ground and sky everywhere. The variability and the fluctuations of these exchanges are getting more and more researched since the understanding of them makes it possible to predict earthquakes. Yeah, I've been talking about strange clouds before earthquakes, like the Bursa cloud in another paper, videos, stuff. The variability. No, we have read this already. Something which is still seen as impossible by many mainstream scientists. The word science is derived from the word nations, which means being in a state of not knowing. Therefore, the only goal of science should be the goal of understanding, but it seems there is a wall of ignorance towards certain things. Despite the international standard of scientific papers being peer-reviewed, which should be or should give it equal credibility in comparison to other peer-reviewed papers, many very important papers in the history of science are ignored. Their recognition would end much of the modern science research immediately. The mystery would cease to exist, and therefore the research too. There would be plenty of research to be done afterwards, of course, but science would make a step further. A paradigm shift would occur. They might also happen in cycles. Yeah, maybe paradigm shifts happen in cycles, like belief systems happen in cycles. It's the year 2024. We are entering the age of Aquarius. Yeah. Jesus brought two fishes because he was representing the age of the Pisces. That is about to end. Yeah, probably I've noticed in recent years the world has changed a bit. But anyway, the ongoing paradigm cycle lasts already for approximately 150 years. It is time for a change. Science seems to have settled to keep alive the mere mysteries. Like monks in a monastery, the modern scientific community will continue to refuse systematically to take in any new information, defend their own truth as the only one, and will be repeating the same mantras over and over again. Yeah, traditional thinking, they call it. Yeah, that's an oxymoron. You either think or you keep on your tradition, but you cannot think traditionally. It's just not possible. But anyway, they also like to keep mysteries alive because it's the easiest way to keep the money flowing into their businesses, such as geological survey institutes or the research for black holes. Their goal is to make as much profit as possible, which has absolutely nothing to do with the search for truth. The amount of evidence their paradigm is wrong grows daily. Many of the clues haven't been hidden. They were there, in plain sight, all the time. We just watched them from a different perspective and use an open mind. It is very interesting to research locations where earthquakes occur. Yeah, I made hundreds of videos about this. Maybe I should make one again. They are interesting. You never know what you find. Yeah, basically, I always know what I'm gonna find, but it's every time different. Are there water veins or other water bodies? Do we find any signs of possible recent activity? Are there thermal springs, glaciers, concrete, or other mining operations? Caves, lakes, rivers, mineral water springs, holy places like churches or monasteries, dams, etc. in the vicinity of the quake? All these are very important clues which should be taken into account in order to get a more holistic picture of the situation that takes many aspects into account other than just geology. The following picture is from Google Earth. I found this picture while checking out an earthquake in an interesting region of the Alps. It is a very nice example of an energy exchange between Earth and sky. Maybe it could be called something like an alpine urchin spine, since the primary principle is the same. So here's the quake, Brennerbad, Sterzing, Italian. A little bit more zoomed out. And here's the picture that is in very bad quality. Sorry for that. But anyway, I think we can recognize a mountain here and we can recognize the cloud that very obviously is going up there into the sky. And maybe here on the right side is something similar going on too. Yeah, like this picture, also from Google Earth. Watching a glacier, a random picture made by Michael Gorski. That's just yet another example for plasma activity around mountains. I had to sneeze, surprisingly, but anyway. Alpine tune antenna, that's just another example for the same thing. There are many. Yeah. The healing spring was first mentioned around 1400. Prince Sigismund, the rich in coins, maybe a pimp, and his wife Eleanor of Scotland were already looking for relaxation around here in 1460. Yeah. So we have an earthquake, maybe two. There are many, maybe. It's probably the same, I guess, I used here. but there are some earthquake spots within the Alps. We have thermal springs, and we have obviously something that looks like, in a way, like a volcano. If you wouldn't know that's in the Alps, this picture, and I would tell you, like, tell me, what do you think where this mountain is? With this picture, let's say it would be a bit better quality. But anyway, you can see probably what I mean. Many would say that, yeah, maybe Southern America or something. Yeah, no, it's the Alps. Yeah, mountain water we are talking about. We are still talking about Valencia. Yeah, just in order for you to remember why I bring all this up, we have the mount volcanoes here. And Valencia is in between these two marked volcanoes. There might be many others. As I try to explain to you, everywhere where we get water pouring out of the ground is basically volcanic activity. And this picture proves, in a way, that the water not only comes down, it also goes up. So if the water is rising here on top of the mountain and it goes into the heaven, we might need to assume that somewhere down below there is water also rising upwards. Okay? We have some Victor Schauberger, more vortices, wide rivers, many places that got flooded recently. Is it Spain or in America or other places? When all the mud that didn't got washed out or something that is still left somewhere dries up, it probably will turn quite white, or rather bright in color. And these are just a few examples of wide rivers. Mount St. Helens in the USA. Talking about pH and voltage. Fire elements. But now we have to talk about floods. Because I'm already talking very long. And still feels I didn't get anywhere. There would be so much stuff still to explain. But anyway, we just go on with the brick floods. Now let's try to remember what I told you about the beginning, or in the beginning, about this one reporter that was really shocked and, in a way, blamed the river. Because the downpour didn't happen in Valencia. The water came from the mountains. Brick floods in 1993. I want to bring forth the example of the Brick, Switzerland floods, which happened in the year 1993, the same year as the Mississippi River flooded in North America. Large parts of the city were destroyed. The official explanation was that heavy rain triggered the floods. Rain was for sure part of the whole event, but the amount of the water that flooded the valley was staggering. Didn't we hear about the same words from the people from North Carolina, Spain, and other places? That the water amount was staggering? It surprised everybody, not only the amount itself, but also the very quick rise. As visible in figure 20, the water rose so quickly that people couldn't bring their cars into safety. Brig is situated in one of those main valleys in the Alps, not too far away from the Alps' biggest glacier, the Aletsch Glacier. In the valley itself flows the Rhone River, which discharges into the Mediterranean Sea. Brig also has geothermal activity. Yeah, I didn't really watch out for or check out the geothermal potential of the Valencia region or North Carolina, especially, or something like that. I wouldn't be surprised if you would have something like that too there. Actually, I would expect something like this. Brig has also geothermal activity, which is used for a thermal bath. A new geothermal energy plant is planned there too. Furthermore, is there also a mineral water spring in relatively close proximity to the city, around 10 kilometers, but about 1,800 meters higher, is Lake Portel, a small lake with a crater or caldera-like form. From close inspection of satellite images, it is obvious the edges of the lake contain different layers of sediment. Some seem to be piled up in a manner like you would expect where there is high water and fine-grained sediment involved. Yeah, fine-grained sediment involved? Let me show you something. For this we have to go over quickly to my channel and we go to the playlist. Yeah, still, if you are bored, check out my solar cycle 25 predictions. I don't know, maybe I am the only one who said from the beginning that this solar cycle will be much more intensive than anyone expects. You can check the videos out, the oldest are about 2 years old or something, saying the same thing. And obviously, it seems to be true. That's a picture from a glacier in the Alps on top of a mountain where we have fine-grained sediment coming out of the ground. And it melted the ice on top of it. Yes, it did. Anyway, clay. These are some videos about clay. How could snowfall possibly create these patterns? Mont Bovin. Let's go and check it out. And I think I totally mispronounced that. Mont Bovin, probably, because it's French. East Bovine, no. Mont Bovin? Let's see where it brings us. If we go to America, we are wrong. No. Yeah, oh, wat heitke. Here is Mont Bovin. Let me just show you that we are on top of a mountain. Okay? Wildstrupel. And they're like very steep mountains. Steep valleys. Yeah. And here we have Mont Bovin. And here we have that feature. Just look at that. How does that look like to you? To me, it looks like there's something coming out of the ground that is warmer than the surrounding area. And there is also something dark within the water, at least it seems like. Very fine-grained sediment. There's another one somewhere here. Yeah, here, check it out. That's not as pronounced as the other one, but nonetheless, molten water on top of a mountain. A glacier lake or two. There are many lakes all over the place. In the Alps. Should we check out Lake Bortel as well. That's rather hard to find. Let's give it a try without searching for it. Because it's rather hidden. I think it's here. Yes. Portelsee. Yeah, the quality isn't the best. And it's probably the same pictures I used. And I want to point out the pattern. We will go on talk about this again later. Yeah, it really seems that here is the point where we have the water going into all directions. That seems to indicate that it is coming from below. Yeah, where we have the Lake Porto. A small lake with a crater-like or caldera-like form. From close inspection of satellite images, obvious sediment. Some seem to be piled up in a manner like you would expect when there is high water and fine-grained sediment involved. It is very well possible this lake had an eruption in recent times, at least once. Yeah, because you can see the sediments. This lake is the stream Saltina's source. The Saltina was blamed for the floods. The river Turia is in a way blamed for the floods. So we are here. The Saltina was blamed for the floods. The name Saltina comes from the Latin word saltare, to jump, and has records of flooding as early as the 14th century. We have to assume the stream's name is no coincidence and can be seen as a warning from the ancient people. Like earlier mentioned, many hints were there in plain sight all the time. Many just have been overlooked or they aren't taken serious anymore because for a long time nothing happened. The knowledge died out. Yeah, remember the pile dwellings? A huge amount of water poured out of it in a very short amount of time. Like I'm talking about the Portal Lake now, where the Saltina River has its origin. The water was quite likely perfectly drinkable in quality. This possibility should be taken into consideration. This is an assumption based on the absence of news about the water being poisonous. Because many of these types of mountains which spill out drinkable water and carry glaciers are actual volcanoes, it makes sense that no one expected them being actual volcanoes. The floods in Brick were perhaps a non-poisonous cold lahar, a flash flood, which is related to volcanic activity. Bad weather, heavy rain, and lightning were documented at the time of the event, indicating a huge electromagnetic potential was provided from the atmosphere. As much as the water which drops from the sky has different speeds according to the strength of the discharge, lightning may also reach upwards from the ground towards the heavens. Possibly, a weather system with enough electromagnetic potential could trigger an eruption from a sleeping cold water glacier, i.e., a cryptogazier. Yeah, I've been talking about cryptogaziers and cryptodomes many times. We are looking at the Lake Bortel. Here you can see in a way the caldera-like shape. Here we can again watch at the ice patterns and the sediments. The thermal bath and geothermal plant and the Lake Portal in very close proximity. And this is just one example, and probably if we just would draw a circle around that area, there would be many other things to find relating to what we are talking about here. So that's just a very gentle scratch on the surface. Conclusion. Possibly glacier carrying mountains and mountains with craters on top, which are fed with groundwater. Hence, lakes should be called cryptoglaciers because they are active geological features. They should be treated with respect because they can be very dangerous. Millions of people live within the Alps region, many probably totally unaware of the danger potential of their environment. While glaciers are considered as contemporary lava streams made of water, which means it is part of a volcano which do erupt with water, each according to its own frequency. So now, for people living in lower latitudes or altitudes where you don't have long term or times of freezing temperatures, every water stream, like if you just would imagine, there would be something like an ice age coming and the temperatures would drop in the northern hemisphere. Many of the wells where we had water pouring out, let it be, let's say it again, North Carolina or the Alps or Spain. If the temperature drops, the water sources, the points where the streams and lakes and rivers starts in the Alps or mountains, they probably would freeze over on top, but they wouldn't stop bringing forth the water. So first the lake freezes over, and after the whole lake froze over, the water continues to push through the rock upwards. So it will start to push the ice downhill. In other words, we get a glacier. And I have witnessed something like this year on a small scale, but it's the exact same principle. Let's have a quick look at this still. Yeah, so that's my second trip to the mini glacier. That's the exact same principle. There is artesian water, in other words, water that's coming from beneath our feet, pushing to the surface. And it has been warm and quite much of the snow and stuff melted. And then it got very cold again. And as you can see, maybe in the background it's windy. It is about minus 10 degrees. And I'm maybe 20 meters from the shore. Sorry for whistling again. But we have, let's say, wet ice, like parts of that ice shelf is wet and parts are dry. So there's different kinds of ices, let's say. And if you follow this little stream, there you go to the lake. And this is I've been writing about this area that's very close to it's at the plasma rock site basically. And I found a geological map where it has been indicating that there is a slightly elevated geothermal potential in the region. And I have been thinking about how to find that. I never thought that I actually would find anything. How could I find a slightly elevated geothermal potential without any tools? Yeah, like this. You just go at the right time, at the right place, and you'll find it. And you can see the stepping and stuff like that. There might be an indication for the rhythm of this well, how it's erupting. Or I don't know. That's very interesting. Very, very interesting. And for me, the best claim, you don't need snowfall in order to get a glacier. People, learn this. You know, you need colder temperatures. What do you think? Like people from the Appalachians if it's getting colder and your water springs freeze over, they won't stop. They just continue. But it's just a glacier. What do you think? How much erosion does this ice do to the area there? Nothing. It looks basically the same after the ice has melted. There's nothing going on. It just freezes over and then it melts. Ta-da! Maybe a leaf moved a few centimeters. That's it. All the heavier stuff just melts through the ice to the bottom. Like if you throw a stone on that, it probably just melts through the ice. And if we scale that up with the rock, the question is where the rock did came from. Like there are many places here in the area, here in Finland, where they are explaining that all these accumulations of sediments, they are brought here by glaciers, but there is no way how could the glacier gather all those different rocks and bring them all here in one place. Rocks from very many different places. Yeah, glaciers don't really wander around the area. Well, anyway, let's go just quickly to the end of this paper. This explains glaciers in a totally different context from the commonly accepted science. By the way, Grímsvötn volcano in Iceland is one of Europe's biggest volcanoes, and it is buried under Europe's biggest glacier. And this is maybe not so much of a coincidence after all. Yes. Yeah, thank you, Bruce Leyburn, for the help with this paper. With my English. Yeah. He showed very great patience. We had a lot of fun, especially about my English. Yeah, now we have to go on still. Oh, not too fast, because it's going on, my paper. There is like all those links, you can go through them. Velikovsky, Hollow Science. There's 80 references, not too many. If you check out my plate tectonic papers to part 3, there is about 145 references. And there wasn't any help by doing that other paper. But anyway, Mountainwater additional evidence. The process of learning should be driven by curiosity and based on the honesty towards oneself. Does anything of this make sense? This question, which should be asked every now and then, and it has to be answered honestly. If it doesn't make sense, the idea must be thought over at least. My research about this topic is far from over, and the new evidence appears daily. Yeah, or after a while, like the Appalachia or the Valencia incident. To me, they are very well going with my theory. This substitute shows 3 things which I thought are so important pieces of evidence worth adding, but weren't included in the paper. Naica Crystal Caves, Mexico. Poas Volcano, Costa Rica. Possible hydrogen emissions related to cryptodome activities. Naica Crystal Caves, Mexico. In the year 2000 in the region of Chihuahua, in Mexico, a very exceptional cave was discovered. It contains selenite gypsum crystals in supersize up to 12-meter longs and several tons in weight. The cave is usually filled with water. It has been kept dry for a few years in order to study it. The conditions in the cave are very extreme, which made the examination difficult. The air has a moisture content of some 99 degrees and the temperature is around 55 degrees Celsius. Yeah, sounds like a sauna. A picture from the cave in Mexico. Note the human for size comparison. Now, I can't make a recap, but I have been talking about huge crystal caves when I was writing the Mountainwater paper. And then it turned out that they are existing. Obviously, someone has been there. Conclusion. The existence of massive caves filled with water and massive crystals is therefore proven. There might be similar kinds of caves in the Greater Alps region too. Yeah, I know about some caves in Spain with huge crystals and stuff. Maybe some of them are in the around the Valencia area. I don't know. Could be. Poas Volcano, Costa Rica. In my paper, I talk about crypto glaciers, so volcanoes that erupt with water. It is a term I invented in order to describe water sources which could produce sudden and unexpected, rather large eruptions, mostly by water. We have to keep in mind that the main trend in geothermal, volcanic, and seismic activity has been decreasing for a long time, maybe several hundreds of years, as a possible indicator of decreasing geothermal activity. We could take the abandoned castles in Central Europe. The reason for them having been abandoned might not only be political, but also the well which provided the inhabitants with water dried up. Another example could be some findings by archaeologists which find ruins, Roman baths, but no water. We are talking about cyclical events, so we have to conclude the activity might increase once again. So could be more water coming. According to observations, we are experiencing an increase in all of these right now. We had the La Palma, Spain, Fagradalsfjall, Iceland, and the Tonga volcanic eruptions, which were all significant, and they might be a good indicator for seismicity increasing. Furthermore, we have to understand that back in the days of the Romans, for example, the geothermal activity in Europe might have been much bigger than it is nowadays, meaning that many places are by far not as active, hot, or rich in minerals as they were several hundred or even thousands of years ago. Yeah, but they could get active again. Bruce Leyburn brought the Poas volcano to my attention because its eruption style is often described as a giant glacier-like eruption. Yeah, the Poas volcano has also acidic lakes and stuff like that. It can produce water columns up to 4 kilometers high. A giant glacier indeed. Poas volcano is a very interesting volcano consisting of different parts of activity. It contains also one of the world's most poisonous lakes with a pH of almost 0. The volcano has 3 different lakes and each has its very own personality. Conclusion. Giant glaciers are existing and are not something needed to be imagined. Yeah. Possible hydrogen emissions related to cryptodome activities. We are talking about clouds. Central Europe is mainly calcareous stones such as limestone, granite, dolomite, marble, etc., like the Appalachians. Most likely the different stones are made from the same base matter which has a high content of calcium, and the different stones are different stages of electromagnetic altering processes. Elements transmutate if altered electrically. For example, potassium transmutates into calcium. The geothermal potential of the region is rather high and water is found everywhere, pouring out of almost every mountain, flowing as rivers in the valleys and forming lakes. Like shown in the paper, clouds are often seen lingering in mountainous regions. Sometimes the clouds are very close to the mountain and the only clouds in the sky. This could have something to do with a certain storability of heat of the rocks due to their density as a material. It could also have something to do with the geoelectric conditions, shape and form or circumstances, but also with certain chemical reactions. All chemical reactions are electrical in nature, i.e., a matter of valence transfer is taught in any basic chemistry class. This is just something so important to understand that I mention it again. Some time ago, I learned that if you drop pure calcium into water, it starts to react and releases hydrogen gas. Hydrogen is highly flammable, but it is also a part of water. I think it would be possible that through changes of the geoelectric environment, water rises within the mountains upwards, maybe not as a stream of liquid water, much more as a cloud within hydrophytic materials. It could be called endogenous cloud. Yep, I'm pretty sure you never heard this word, endogenous cloud. As this cloud of H2 moves within the mountain and comes in contact with calcareous rocks, the chemical reaction takes place. Hydrogen gas gets released, which eventually makes its way to the surface, where it immediately starts to bind with oxygen and water gets created. Yeah, the clouds. Since we are talking about gaseous substances, we would also expect water to be in this state, and this is what we see clouds. The hydrogen might be emitted by the mountain in certain places through two mechanisms. First, the most obvious cracks in the rocks. Water seeping through it. The second is quite likely related to electromagnetic fields and energy flow patterns in the mountain itself and its role in its energy field. In the same paper I talk about the glacier that possibly contains iron. It would make it an iron mountain in a way. The clouds are visible for everybody. No special equipment is required and totally for free. Hydrogen is very abundant in nature and probably hard to detect since it teams up with oxygen and forms water. Maybe the obviousness of this geological process is what kept it obscured from common science. Undoubtedly, also precipitation plays a significant role in these processes. For example, rain or meltwater can also penetrate deep into the rocks, and a similar process of hydrogen release can happen. Maybe that's why the mountains are usually covered with clouds after rainfall. The importance of calcium in alpine environments is also from interest to other people. They also found interesting evidence about certain connections between pH and altitude. Maybe that's one of the reasons for why there's no trees up in the mountains, but anyway. Conclusion: this theory still needs much more exploration, but I think it is an important aspect to take into account in order to get a picture as coherent as possible. Maybe the hydrogen anion is the white rabbit. Through its negative charge and great abundance, it could be the root and source of all alkalinity, the reason for why the white rivers are white, and why Earth is a blue marble. Earth's surface has a net negative charge, as earlier shown with Thornhill's repellent core, so it might be no coincidence that hydrogen accumulates at the surface and makes life on Earth possible. In the Perkin current, hydrogen and oxygen are also found on the outer side. Let's end still with a quick visit on Wikipedia. Turia River. The Turia, or Turia, Valencian Turia, is a river in Spain which has its source in the Montes Universales, in the mountain ranges of the northwesternmost end of the Sistema Ibérico Teruel province. From its source, I want to point out that this river has a source. That is very important because this makes the connection from the sea to the mountains. It has a source. I don't know. To me, that's a very important point. It means basically that it's not just gathering from rainfall, and there's just water flowing out every now and then. No, the river has a source, so it's flowing there always, basically. From its source to roughly to the city of Teruel, it is called Guadalaviar. Guadalaviar River. Maybe this means something interesting, but anyway, maybe Turia means something interesting too. It runs through the province of Teruel, Cuenca, and Valencia, and it discharges into the Mediterranean Sea. Near the city of Valencia, the river formerly ran through the center of the city, but was diverted south of the city to prevent flooding. Guadalaviar. Yeah, this looks very limestone-ish water to me. The Latin name Turia, also recorded as Turius, has been connected with the Celtic root dubr. Dub means black. Dub. Anyway, the river would thus share a root with the Douro. Oh yeah, there's like two rivers at the same place in a way. It's shedding at the very point. The river is notorious for its floods. Yes. Like the Saltina River in Switzerland, it carries the name to jump. It's known because it probably might be just more than water from rainfall accumulating. The flood, which occurred on October 14th, 1957, known as the Great Flood of Valencia, flooded large parts of the city of Valencia and caused a great deal of damage to both life and property. To prevent this from happening in the future, a diversion project was devised, Plan Sud in Valencia and Plan Sur in Spanish, completed in 1969, and the river was divided in two at the western city limits near Quart de Poblet. During the floods, most of the water is diverted southwards along a new course that skirts the city until it meets the Mediterranean. The old course of the river has been turned into central green space for a city, a cultural attraction known as the Garden of the Turia. Yeah. That's the source of the river Turia. And I would say, looking at this picture, you can see there is this kind of greenish, yellowish stuff here growing. Quite likely some algae, I guess. That indicates that there is something in the water that makes it possible for the algae to grow there. In other words, it is charged water. Limestone-ish water. That makes the whole story very interesting. What do you think would happen to this well if the overall temperature just would go down below zero? It probably would freeze over. Would the water would the water stop coming from below? I don't think so. It just would continue, and it probably would form a glacier. And there might be, I don't know how old this picture is. Source of the Turia River. It would be very interesting to get a picture now from the same place. Is there some change going on? Has there been any change? Because it seems that there is something around that too that looks different from the surroundings. So there might be more to the source of this river than just this. Yeah, but I think I leave it here. This was a very long video, and I still feel there's so much stuff still unexplained. But anyway, you can check out my mountain water videos. There's some more than 300 of them. Read the paper. go through all references. And yeah. We are really, I think, people that are living in mountainous regions should get aware of the possible danger of the water. That is not only falling from the sky, it could also come very likely from below, creating flash floods and stuff like that. Rock falls, of course. The mountains could crumble if there would be a lot of water coming up all of a sudden. Yeah. It's all scalable. It depends on the amount of input into Earth's electrical circuitry. And if you are aware what's going on in the sun at the moment, there is quite a lot going on in the sun at the moment. You may have to take a look. There's like coronal holes, triangle shapes, and the geometry of the holes is very interesting, and the formations of the sunspots is also very interesting. And there are many of both of them. And like it's very, very, very interesting. So many things going on. But anyway, 1.5 hours. Not too bad for surprising myself and making a video. Trying to warn people. Trying to provide something constructive. Maybe even positive. Yeah. Yes, let's leave it here. Thanks. Thanks. Bye.